basically going to introduce the subject of computer aided design. In computer aided design, we normally refer to a number of different kinds of activities. Before we go on to any of those activities, I first want to briefly describe what is normally referred to as computer aided design. In computer aided design, we basically talk of integrating computer science techniques, okay, with or integrating computer science techniques for engineering design. Okay, what that means is any kind of use of computers for doing in the design activity is referred to as computer aided design. This includes a wide variety of usage. This includes a wide variety of techniques that are used. Some are computer graphics techniques, some are simply using computers as programming tools. Okay, we will see what are the different activities that can come under these, or what are the different computer science techniques or computer techniques which have been used in under the design domain. This use would include use of both hardware as well as software. Okay, when you are talking of hardware, different kinds of hardware have been used in terms of screens that you have, the input devices like I think you are all familiar with the mouse. Okay, the other input devices, maybe a ball or maybe a light pen. The other output devices like plotters. So different kinds of hardware are relevant which are specifically meant for CAD activities. There are different kinds of software which have been developed, which are different kinds of modeling software. We will be talking of that in detail. Then we talk of different numerical techniques. Numerical methods. Okay, when I talk of numerical methods, I include optimization, I even include the normal programming, or if we are talking of automation, we just program a particular activity. We are using the computer as a number crunching machine. All those activities are what I include under numerical methods. They can include matrix multiplications, or where very large matrices are involved. They can include solution of partial differential equations. They can include optimization techniques. All these are what I cover under numerical methods. Okay. When we talk of CAD, after numerical methods, the next thing that is normally included under CAD is what is referred to as drafting, which is either 2D or 3D drafting. Okay. When we say drafting, what we mean is the normal drawing work that is done. You have all done a course on engineering drawing. Whatever drawing you do on the drawing board, the same, instead of doing it on the drawing board, you do it on a computer. Okay, that means if you have to draw, let us take a very simple example. If I want to draw this shaft, okay, and I want to give it a dimension something like this, okay, and maybe some length over here, which is, let us say, okay, if I want to give it a set of dimensions like this, I can make an engineering drawing out of this on the drawing board. Instead of using the drawing board, I can do the same thing on the computer using AutoCAD or using some other drafting package. This drawing consists of a set of lines that have been drawn here, okay, a set of arrowheads, a set of text that has been written, and so on. Okay. In this, each entity is a line or an arc. Okay, if you are drawing a, if we have an arc over here, that will be an arc. So each entity is a line or an arc. Okay, and entities are not the complete shaft. We don't have the concept of a shaft right now. We've just drawn a set of lines and a set of arcs. Okay, this is what we mean by drafting. These lines can be two-dimensional lines or they can be three-dimensional lines. Okay, but they are essentially lines and arcs, and we use these lines and arcs to make a complete figure on the computer. Once we make a complete figure on the screen, from the screen I can take a printout using maybe a plotter or a printer. So that is where CAD specific hardware comes into picture. We have specific hardware meant for plotting. Okay, we have specific hardware meant for printing. Okay, the screen will normally be a high resolution screen like a VGA monitor or something like that, and the basic application is the drafting application that we are talking about. Okay, so this is 2D or 3D drafting. The other kind of activity that is normally included in CAD is what we call as 3D or even 2D modeling. When we are talking of 3D modeling, we are essentially talking of representing this object. Okay, now if we are talking of the shaft over here, we are talking of representing this object as a three-dimensional object. Okay, if we have it as a three-dimensional object, let's take this pen. I took this example yesterday also. If I talk of this pen and I represent it as a three-dimensional object on the computer, I can take views from any angle. Okay, if you are taking a front view, you can take a front view like this. If you want to take a top view, you can take a top view. Okay, if you want to take an isometric, that is a view at roughly this angle, so something like this, you can also get an isometric view. If you want to take sections, you can take sections. Okay, so you represent it as a 3D model and then take different sections, different views, get the different views and then dimension them accordingly. Okay, so this is what we mean by 3D modeling. I will just show you some of the slides from these texts. Can you see it on your monitor? Now, in this, you will find a complete scene which has been modeled on the computer. Okay, you see a dining table which has been set, different objects which have been placed. Now, each of these objects has been modeled using some of these techniques. We are able to use this model to visualize what the table would look like. Out here it's a flight simulator. We are able to use this model to see what the scene is like, what are the different objects there and so on, to see it from different angles and to get a feel of the actual situation. Okay, we can have some more examples. Okay, these are objects of different shapes but modeled using different techniques. Okay, this model looks very different from the model that you just saw. Okay, in this the surfaces have been modeled by a mesh of wires. Okay, it's a wire mesh kind of model, wire mesh kind of display that is being used. Okay, but this is also a 3D model. It's a 3D modeling technique which has been used here. Okay. So, the other CAD activity is 3D modeling, and this is a major part of what we mean by computer aided design. Okay, often people refer to this as drafting as computer aided design. Some people even refer to just numerical methods also being computer aided design. okay, because even in numerical methods you are using the computer as an aid for designing, okay. But a major part of this activity of computer aided design comes under this realm of 3D modeling, okay. When you are talking of modeling, it is essentially an aid to visualization okay. You want to visualize the object from different angles, see different corners, see whether different parts are interfering or not. That is what we mean by an aid to visualization, okay. So modeling is used as an aid to visualization. Then when you are talking of modeling, we are trying to model the different curves and surfaces. Okay, if you are modeling a complete solid, we also have to model the curves and surfaces that come on it. Okay, for example, in this object, okay, you are seeing the surfaces which form this solid. Okay, if you want to represent this solid, we also have to represent the curves and surfaces which form a part of the solid. Okay, so when you are talking of 3D modeling, it is not just representing the solid as such. We also have to represent the curves and surfaces which constitute that solid or which define that solid. Okay. So under 3D modeling, we represent curves, surfaces, solids, okay, and so on. All this comes under 3D modeling. Now, once we have represented a 3D model, the next question that comes up is that what do we do with the 3D model? Okay, one we have already said we will use it for visualization. Okay, we want to visualize the object on the screen. It will help us give a feel of the situation, and we will be able to see whether different parts are interfering, whether a particular part in motion is interfering with something else or not, and such things. Okay, so one use is visualization, but another very important use of these CAD models is in analysis. Okay, once we have the model of a particular object, we should be able to analyze it for the different forces that are acting on it. Okay, the different forces, the different displacements that the object will be going through, and so on. Okay, now this analysis can be analysis for stresses. You can analyze it for deflections. Okay, we can also, when we are talking of analysis, we can actually simulate the object in actual use. Okay, that means by simulation what we mean is, let us say if we have a simple mechanism like this, okay, maybe it is a part of a robo arm or something like that, okay, with some maybe gripper attached over here. Now this robo arm is moving in space. From this position, maybe it goes to some position like this. Okay, the path that it takes, this link rotates like this. Along with that, this link is also rotating simultaneously. Okay, we want to be able to visualize how this object, how this mechanism would move in actual space. So we want to simulate its motion and then actually animate it on the screen and see how the motion will take place. Okay, so that is what we mean by simulation. We want to simulate the motion of an object. Okay, another very important application of this kind of analysis is, let us say if we have one object. Okay, this object can be a very complex object, maybe a car or a bus, and we have another object which is maybe another car or maybe a two-wheeler or something like that. They meet in a head-on collision. Once they will collide, there will be some deformations, there will be some forces on the passengers, okay, there will be some stresses on them, stresses on the different parts of the body. Okay, so we want to estimate, we want to see what will happen in the crash. That is crash simulation. So that is also another type of analysis. Okay, all that can be done if we have a model of each of these objects. If you have some representation for this object, some representation for this object, if we have some representation for this set of links, for this robo, and so on. Okay, so all this comes under computer aided design. We are using the computer as a tool for designing each of these objects. Okay, and we are essentially modeling these objects first, then using it for analysis, using special tools for each of these kinds of analysis. Okay, and of course, in under analysis, we have already mentioned optimization. If we have the model of an object, we can use it for optimization. We can use it for optimizing it on optimizing the size for weight and so on, for different criteria. Okay, so the model that is created, that model can be used for any of these activities. Okay. Other than analysis, an important application of these CAD models is this applications of CAD models are in the areas of what we call as CAD CAM integration. Okay. In CAD CAM integration, we're essentially talking of, let's say this is the initial stage, what we call as CAD. Okay, where we are developing a model, we are analyzing the model, and finally designing a particular object. Then we have the manufacturing stage. Okay. Within the manufacturing stage, let's say we have a set of CNC machines. Okay, now this object has to be manufactured on this CNC machine. For manufacturing this object on the CNC machine, for this CNC, the CNC code has to be generated, has to be written now. This code will depend on the object that has been modeled. It will depend on the set of manufacturing steps that have to be carried out. If we have the model for an object, we can use that model to generate this code and to get an interface, to have automatic interface between CAD and CAM. That means directly by a CAD model. Let's say if you are talking of a shaft. If this shaft is represented internally in a proper manner, then from this representation, from the representation of this shaft, from the model of this shaft, we can directly get the NC code that will be required to make it. Okay, we will be able to generate a process plan. Between CAD and CAM, we will have a stage called what is referred to as computer aided process planning. For making a process plan for this, the CAD model that has been made, that will form the input for that. Okay, so CAD models will form an input for computer aided process plan and will also be used for generating the NC code. Okay, so if we are talking of an integrated manufacturing environment, in the integrated manufacturing environment, this CAD CAM integration plays a very vital role. Okay, so under the applications, this CAD CAM interface and of course computer aided process plan, these form a very important, very major application for the CAD models. In fact, there is a whole area which is normally referred to as CIM, okay, computer integrated manufacturing. It refers to CAD, it refers to the process plan that is being generated, and it refers to the manufacturing stage. Okay, this complete stage, okay, this complete cycle comes as a part of CIM, computer integrated manufacturing. Okay, the other aspects also to CIM. Okay, we won't get into that, but this, the CAD model that has been created forms a basic link for each of these stages in CIM. If you are talking of an integrated manufacturing environment, the CAD model is the starting point. Okay. So, if you summarize from this, the three important aspects okay. The first important aspect is what we refer to as modeling. The second is what we refer to as display or visualization. You have modeled an object, we want to display or we want to visualize it. And the third is what we refer to as applications. Okay, the applications would be CAD/CAM applications, stress analysis applications, okay, crash simulation applications, and so on. In addition to these, we have also mentioned numerical methods, okay, as an important part of CAD. Okay, quite often CAD is referred to as numerical methods and optimization. But as a part of this course, we will not be touching upon this part. Okay, in this course, we will essentially be talking of computer aided design as starting from a CAD model. We will be talking of modeling and its applications. Okay, we will not be going into numerical methods, optimization, and other such techniques. So this course is going to talk mainly of computer aided design as consisting of modeling, as consisting of its use in display and applications. The applications, or the main application that we will be talking of, would be stress analysis, and we will be talking of the finite element method. And the other application would be CAD/CAM integration, which we might touch upon. Okay. So this is or the other three different aspects of CAD which we will be touching upon as a part of this course. We will briefly see what are the different activities that come under each of these three. Okay. So when you are talking of modeling, under modeling, the first thing that we want to do is to define an object. Okay, we take a simple object, we want to define it on the computer. Okay, we want to define it using some modeling techniques. The first thing that modeling deals with is how to define an object. That is going to be the first important part of modeling. When you are talking of defining an object, we are essentially saying that we want to relate the different features. Okay, I will just the different features of an object relate different features or relate different objects. For instance, if we consider this shaft, now this shaft is supported on a set of bearings. When we want to model this complete system, we have to define this shaft as one object, this bearing as a second object, and this bearing may be as a third object. And in addition to that, there might be some mountings on it. Okay, maybe there is a gear here or a chain and sprocket here or something like that, and something else connected on the other end. So there might be different objects connected on them. When we are modeling this complete scenario, each of these objects would first be defined. Then we have to define the relationship between these objects. That means this shaft is next to this bearing and is touching it on this surface. Okay, so let us say for this object we are defining this as an origin, and for this bearing maybe we are taking this as the origin for this bearing. We will like to define that this bearing is located at a particular XYZ value with respect to this origin. So that defines a relationship between this bearing and this shaft. Okay, this relationship is a geometric relationship with respect to adjacency, with respect to which object is next to the other object and so on. It defines the geometric location of the two objects with respect to one another. Similarly, if you are talking of this mounting, okay, which can be a, let us say, chain and sprocket or a gear, we will have to define that this sprocket with whose origin is here is at a certain location with respect to this point. This is what we mean by we have to relate different objects. We have to relate them with respect to one another. Relate different features. Let us say if you are talking of a simple block like this. On this block, let us say we have a through hole. This hole is a feature on this block. We will have to relate that this block, let us say whose origin is at this location, this is the origin, this hole, this feature is at a particular orientation with respect to this origin, at a particular distance. Okay. This hole is at, let us say, this face, the top face. This hole is a vertical hole and is a through hole. All this information has to be available when we are talking of defining this object. That is what we mean when we say relate different features. This hole is one feature, this top face of this object is a second feature. We have to relate the two together, saying that this face is next to this hole. Okay. The basic idea that I want to convey right now is that when we are trying to relate different features and objects, a lot of information has to be stored on in that model. So when we are talking of modeling, that includes a lot of information. It is not just defining this object as maybe a block. A lot of information goes into it. So unless we are able to relate these features, we will not be able to use this object in any situation. Unless I know that this hole is at the so and so location, is a vertical hole and is a through hole, unless I know all this, I cannot get the manufacturing sequence for it. For finding out the manufacturing sequence for making a hole, I need to know the location, I need to know the direction of the hole, and I need to know how deep it is. So unless all that is known to me, I will not be able to use this model for any realistic purpose. Okay, that is why we say that when we are talking of defining an object, we have to relate different features of the object. Okay. And another thing related to this that I have already mentioned is that we have to talk of orientation in a coordinate system. We define a coordinate system that, let us say, this is the origin for the shaft, this is the origin for the bearing. The two are, or this origin is at a location xyz with respect to this origin. All that is with respect to a particular coordinate system. Okay, so whenever we are talking of modeling, we are doing that with respect to a particular coordinate system. We have to define a coordinate system and give all our dimensions with respect to that system. Okay. And then once a model has been made, in any design situation, the model will never be static, meaning that the model will change from time to time. I have made this model, but then I find the thickness of this plate is too small. So now I want to increase the thickness. So I want to go and make a change. Okay, the moment I want to make any change, that means, let's say if I want to change the thickness, in this figure I will have to increase this size, make this change, and then rub out all these. If I am doing it on the drawing board, I will have to make all these changes. Okay. So when I am talking of making these changes, we refer to this process as a process of editing. Editing an existing model, or making changes in an existing model. Okay. So once a model is available, then we talk of what I refer to as display or visualization aids. When you are talking of display, we are talking of displaying model objects. When we talk of displaying the model objects, what we basically want to do is this object, we want to map it onto screen coordinates. That means if we have a simple block like this, the block, let's say for this block I am taking this as the origin, the width is maybe 500, height is 400, and the depth is maybe 300. If I am taking a particular view, which may be, let's say, an isometric view, something like this. Now this view has to be drawn on the screen. So on the screen, the orientation of the location of each of these points has to be defined. So on this screen, if I am taking this as my 0 0, I have to decide that this 0 0 0 over here has to map to which point on this screen. That means every point of this block has to be mapped on to a screen location. That is what we mean by mapping onto screen coordinates. If I am able to map every point on this block, then I can draw the object on the screen. So when we are talking of displaying or visualization of that object, we are basically talking of taking that model object, for each and every point we find a corresponding point on the screen coordinates. Okay, that is what we mean by display. In this display, if we have surfaces, then these surfaces might have to be shaded. Okay, if I have a simple cylinder like this, for a engineering view of this cylinder, I need not bother. I can just take a front view and a top view and make my 3 orthographic views. But for visualization, I might like to get a shaded view. Okay, if I am taking a shaded view, it will look something like this, depending on where the light is placed. So when we are talking of displaying, I should be able to take any object and display it on the screen, show it on the screen, depending on what is the location of my light source, what is the nature of the surface, whether it reflects a lot of light or whether it is a diffusing kind of surface, and so on. Okay. So when you are displaying surfaces, we will talk of issues like shading, and we will talk of what is referred to as hidden surface removal. If I am trying to make a view of a simple block, if I am displaying all the surfaces, this is what the view would look like. And it's easy to see that this view is confusing. It's not easy to make out which surface is in the front, which surface is at the back. Okay, I can't make out whether this surface is in front or whether this surface is in front. So normally we like to remove the hidden surfaces, the surfaces at the back which are not visible, the edges which are not visible. We like to remove those lines and edges. So instead of drawing it like this, we like to draw it just like this. This would improve the clarity of the presentation. It will help in visualization. So when we are talking of display, we like to remove hidden lines. Okay, this is normally referred to as hidden line removal or hidden surface removal. Then when we are talking of display, we will also like to talk of projections. If I take an orthographic view or a front view, simple front view of this object, I will get a rectangle. If I take a isometric view, I will get a view which would be something like this. Okay. If I take maybe perspective view, I will get a view which would be something like this. If I have modeled this object, that is, if I have given a geometric description of each of the surfaces and each of the edges, if all that information is available with the computer, I should be able to generate any of these views depending on the direction from which I am looking, depending on my specifications given. I should be able to do these projections. We will be seeing methods for each of these tasks. We will see how projections can be obtained, we will see how hidden surfaces can be removed, we will see how simple display of lines and curves can be done. We will also see how the shading can be done. All these techniques we will be covering as a part of this course. Okay. So from all this, we can conclude that if we are talking of modeling, modeling has different requirements. The first is that solids are modeled or have to be modeled by storing information of constituent surfaces. If I have any solid, I cannot represent the solid unless I am able to represent the surfaces. Okay, because my different features will be on the surfaces. If I have a hole or if I have a slot, if I have a groove, they will all be on the surfaces. So all my surfaces will play an important role in defining the solids. Okay, so we say that solids are modeled by storing information of constituent surfaces. Similarly, when we are talking of displaying surfaces, we will also have to talk of curves. Because if I have a surface like this, I cannot represent this surface unless I am able to represent the edges of this surface. Okay, so if I am talking of surfaces, curves are also equally important. Then if I am representing or if I am storing information of with respect to surfaces and curves, this would help us in firstly displaying the surfaces. Okay, so this would help in displaying surfaces. That means if I have to display any object, how do I display a solid? The only way I can display the solid is by displaying all the boundary surfaces. In this simple example, when I am trying to display this solid, what I am basically doing is I am displaying each of these surfaces one after another. Okay, so I cannot display a solid unless I am able to display the surfaces. So this storing information of constituent surfaces is going to help us in displaying the surfaces. It will also help us in computing solid properties. What we mean by solid properties? For this object, if I want to find out the weight of this object, okay, or if I want to find out the volume of this object, moment of inertia of this object, I should be able to do that. I cannot do that unless I know what are the bounding surfaces. If I know the bounding surfaces, I can find out the weight, I can find out the moment of inertia and so on. Okay, so this information is going to be important in computing the solid properties. Then I already mentioned that solids are modeled by storing information on surfaces, and surfaces will be modeled by storing the information on the curves. Okay, so this relationship between solids and curves is well represented by this diagram. Are you able to see it clearly? Essentially what it says is that if you want to represent any volume, okay, a volume is delimited by or is bounded by a set of surfaces. Surfaces can be either plane surfaces, okay, that is planes, or they can be warped surfaces, okay, warped surfaces or curved surfaces. Whether they are plane surfaces or whether they are warped surfaces, the boundaries will be different kinds of curves. Okay, so if we have a curve, can be a boundary for a warped surface, it can be a boundary of a plane surface. We can also have a family of curves which define a surface, okay, a network of curves or a set of curves which define a surface. For instance, if we take a set of curves like this, Okay, we say this is a family of curves, one set of maybe cubic curves in one direction, other set of cubic curves in the second direction, and this defines a surface patch. Okay, so we can have a network of curves, or we can have patches which can define a warped surface, or which can define a three-dimensional surface. A curve can consist of a set of curve segments. What do we mean by a set of curve segments? We have a curve from one point to a second point. Then we have a different kind of curve from this point to the next point, and another kind of curve from here to here, and so on. Okay, so a curve can consist of a set of curve segments like this. So curves can consist of a set of curve segments, and curve segments would be defined by endpoints and other geometric properties. Okay. So if we want to represent a solid or a volume, this solid or volume will be represented by surfaces which are represented by curves, which are in turn represented by curve segments, which consist of points. If we have to describe solid modeling techniques, we cannot describe them unless you have some idea of how to represent curves and surfaces. The basic method of representing any solid is always going to have methods of representing curves and surfaces embedded in it. So the basic idea is that when we talk of modeling surfaces or modeling solids, before that we will be talking of curves and surfaces and their modeling techniques. So in this course, we will first talk of different methods of, when we talk of modeling, we will first be talking of different methods of representing curves, different methods of representing surfaces, and then we will talk of different methods of representing solids.
So you talked of curve segments being defined by endpoints.
What's the question again?
You defined curve segments
Yeah.
being defined by endpoints. That is to say, curve segments essentially lines.
Okay, I'm glad you put that question. Actually, instead of endpoint, I should have said control points. That is a better way of saying that. If we have a curve starting from this point, ending at this point, you're right, if I just specify 2 points, I can only have a straight line between them. But if I have a set of control points, I can have a set of points here. This is a set of control points which define this curve. Then I can have a curve either as a cubic curve or a higher degree polynomial curve, depending on the modeling technique I am using. Okay, if I am using 5 points, if I am using 10 points, I will have a curve of the corresponding degree. So the curve will be modeled not just by the endpoints but by a set of control points. Or if I am just giving the endpoints, I will also be specifying something in addition to that, maybe the direction of the tangent over here or some such related information. Maybe I will specify the direction of the tangents plus I will specify that this is a second degree curve. Then maybe endpoint, just endpoint would be sufficient. Okay, but the basic idea in this figure is that if I have to represent a curve segment, I cannot do that without storing the relevant points in there. The relevant points will be the set of control points, including endpoints, including some other information in terms of tangents and so on. So you're right, it won't just be the endpoint or the start point and the end point, but it will also be a set of control points which will be important for every curve. Okay. Any other question? So if there are no more questions, then I'll end now and we'll start from this point in the next class.